Fission yeast might not look like much. It's a single-celled organism that spends its entire life doing very yeast-like things, growing, dividing, and occasionally helping scientists ruin Friday night pizza experiments. But don't let its simplicity fool you. This humble microbe, Schizosaccharomyces pum, is turning out to be one of our most unlikely allies in the quest to understand human aging. Think of it as a mini-human, without the taxes and existential dread, but with surprisingly relatable cellular machinery. The big reason scientists love fission yeast is that for something so tiny and ancient, it shares a remarkable number of biological pathways with us. It has many of the same genes and regulatory systems that humans do, including those involved in DNA repair, cell cycle regulation, metabolism, and, yes, aging. In fact, around 70% of the essential genes in fission yeast have clear human equivalents. That makes it a perfect living laboratory, easy to grow, quick to manipulate, and willing to reveal biological truths without the logistical nightmare of running a 90-year human trial. Fission yeast ages in a surprisingly human-like way too. Unlike its cousin Saccharomyces cerevisiae, baker's yeast, which divides asymmetrically and accumulates damage in the mother cell, fission yeast divides symmetrically, just like many of our own stem cells. This makes it a much better model for studying replicative aging, how many times a cell can divide before calling it quits, and for examining how cellular damage accumulates or doesn't over time. Now enter caffeine, stage left. You might think of it as your favorite brain fuel, but in the world of yeast, it's a compound with profound genetic implications. In fission yeast studies, caffeine has been shown to extend lifespan, especially when the TOR pathway is involved. TOR, the master regulator of growth, responds to nutrients, and when it's suppressed, either by fasting or by certain compounds like caffeine, cells shift toward maintenance and stress resistance. In experiments, caffeine appears to act as a mild TOR inhibitor in yeast, triggering a cellular state similar to calorie restriction. Essentially, caffeine tricks yeast cells into thinking they're a little hungrier than they are, prompting them to clean up damage, recycle components, and stretch out their lifespan. But it's not just about caffeine. Fission yeast has been a goldmine for studying the genetics of longevity. Scientists have used it to uncover genes that regulate lifespan and resilience to stress. Genes like sirtuins, AMPK, and TOR, all of which have human equivalents. Want to test how a mutation affects the ability of cells to survive DNA damage? Or how caloric restriction interacts with genetic pathways? Fission yeast will give you answers in days, not decades. Even more exciting, yeast experiments have shown that you can dramatically extend lifespan with tiny tweaks in nutrient-sensing pathways. For example, knocking down genes involved in protein synthesis or growth can double or triple the yeast's lifespan, suggesting that aging, at its core, might be more about how a cell interprets its environment than how old it technically is. These insights help scientists understand why interventions like fasting, exercise, or certain drugs seem to work so broadly across species. And here's where it gets poetic. The same stress resistance pathways that extend the lifespan of yeast also protect against age-related diseases in humans. Mitochondrial function, protein homeostasis, DNA stability, oxidative stress response. All these systems that start to falter with age are evolutionarily conserved. What improves them in yeast often does the same in worms, flies, mice, and sometimes humans. So yes, fission yeast doesn't have a brain, or a liver, or a Netflix password. But it does have TOR. It has AMPK. It has autophagy and oxidative stress and chromatin remodeling. It has caffeine sensitivity. It ages. It dies. And in between, it tells us how to live longer, not by magic, but by studying the machinery we've shared for over 1 billion years. In a world full of high-tech longevity startups, protein bars that cost more than gold, and wearable devices that monitor your every heartbeat, it's almost hilarious and incredibly humbling that some of our best anti-aging clues are coming from a single-celled organism quietly multiplying in a petri dish. But that's science for you. Sometimes, the key to human longevity is hiding in a yeast cell, waiting for a jolt of caffeine.